Welcome to Introduction to AI and Machine Learning. This is the first in a series of AI training videos and is designed to give you a clear conceptual understanding of artificial intelligence and machine learning without technical complexity. Our aim is to make these concepts accessible to everyone. Video Introduction. This course is appropriate for all levels of expertise in AI. Why is AI important? AI has the potential to improve and streamline processes and support decision-making. However, it's essential that we use AI responsibly, as it can also make epic mistakes. Learning objectives. At the end of this video, you will have a conceptual overview of how different subsets of AI fit within the whole. You will also understand the different types of machine learning and what they're best suited for. Finally, we will examine deep learning with artificial neural networks and examine how it is inspired by the human brain. Foundational concepts. Artificial intelligence, or AI, is the broad field of making computers mimic human intelligence. Machine learning, or ML, is a subset of AI where systems learn patterns from data to make predictions or decisions. Deep learning is a further subset, using multi-layered neural networks to model complex patterns in large datasets. Generative AI creates new content, such as text or images, and large language models like Copilot and ChatGPT can understand and generate human-like language. Don't worry if any of these terms seem abstract right now. We will explain them all in detail. Rule-based programming. Rule-based programming makes decisions using predefined rules, such as if-then statements. For example, if a patient's temperature is above 38 degrees, the system flags a fever. While useful, rule-based systems are limited in adaptability compared to machine learning. Machine learning basics. Machine learning is about learning from data instead of just following predefined rules. This makes machine learning solutions less rigid and more sensitive to nuance. Based on how machine learning models are trained, there are three main branches: supervised learning, unsupervised learning, and reinforcement learning. Let's see how they work. Supervised learning. Supervised learning uses labeled examples, where the correct answer is known. The goal is to predict outcomes for new data based on patterns learned from labeled data. For example, an image labeled as apple teaches the model what an apple looks like. In healthcare, supervised learning can help predict disease from X-rays labeled as normal or abnormal. An example from the everyday human perspective is by seeing a variety of dogs, we learn the key features that make something a dog. So, even if we come across a breed we've never seen before, we can still recognize it as a dog. Supervised learning works in much the same way. By learning from labeled examples, it can identify new cases based on what it's seen before. Unsupervised learning. Unsupervised learning finds patterns in unlabeled data without prior examples. The goal is to discover hidden structure or groupings in the data. For example, clustering similar items by color. Unsupervised learning can help with risk stratification, anomaly detection, and pattern discovery in clinical data. A common everyday example of unsupervised learning is found in the recommendation engines of streaming platforms. These systems analyze a user's past movie or music choices, along with how much of each item was watched or listened to identify possible preferences and suggest new content. Reinforcement learning. Reinforcement learning is about learning by trial and error with feedback from actions. The goal is to maximize rewards over time. For example, navigating a maze by trying different routes. In healthcare, reinforcement learning can be used in robotics, gamified learning, and treatment planning. Imagine learning a new language or how to dance. Each time you practice, you get feedback. Maybe you pronounce a word correctly or master a dance step, and that's a reward. If you make a mistake, you adjust and try again. Over time, you learn the best way through trial and error, guided by feedback. In AI, reinforcement learning works in a similar way, helping systems improve their performance by learning from experience. Deep learning, biological and artificial neurons. Deep learning is the subset of ML that is inspired by the brain. A biological neuron receives signals through dendrites and sends signals through the axon. An artificial neuron receives inputs, multiplies them by weights, sums them, applies an activation function, and produces an output. Each neuron is simple, but many together form powerful networks. What makes it deep? Deep learning means neural networks with many layers of artificial neurons, just as the brain is a network of biological neurons. Layers include input, hidden layers, and output. Deep learning learns patterns automatically from raw data but needs large datasets and high computing power. In healthcare, deep learning is used for analyzing medical images and predicting disease risk. Deep learning isn't limited to just one type of machine learning. In fact, deep learning can be used in supervised, unsupervised, and reinforcement learning. Knowledge check. Question 1. Which of the following best describes supervised learning? Learning from labeled examples. Finding patterns in unlabeled data. Learning by trial and error with feedback. Answer A. Learning from labeled examples. Question 2. What makes deep learning deep? It uses a single artificial neuron. It uses multiple layers of artificial neurons. It only works with biological neurons. Answer B. It uses multiple layers of artificial neurons. Summary. Artificial intelligence and machine learning are transforming industry by supporting decision-making and improving prediction. Machine learning uses data to learn patterns and make predictions, with three main types: supervised, unsupervised, and reinforcement learning. Deep learning takes this further, using multi-layered neural networks to tackle complex tasks and large datasets across all types of machine learning. It's important to use AI responsibly, always following best practice. To continue your learning, watch the other videos in this series. You've now completed the introduction to AI and machine learning. Remember, the goal is to understand how these technologies work and can be applied effectively to solve problems. Thank you for taking part in this first course in the series. If you found this helpful, don't forget to like and subscribe, and check out the other videos in our Introduction to AI and Machine Learning series. You'll find the links in the comments below.